Welcome to our third video on inequalities. Today we're going to expand our two previous lessons into solving multi-step inequalities. These problems are going to be very similar to when we were solving two and multi-step equations, only this time we are still applying our rules of inequalities. The two things to be careful of are when I multiply or divide by a negative, and then making sure we write our answer in full, including the number line. Let's start by jumping in and solving our first example. Negative 11y minus 13 is greater than 42. Well, to start, like any other two-step, I should work on getting the letter by itself and all the other numbers on to the other side. When we did two-step equations, we would always start by adding or subtracting the piece without the variable. Well, that's right here with the minus 13. Since there is no variable on the 13, let's go ahead and remove it and place it to the other side. Our rules state in order to get rid of a minus 13, I have to add 13 on each side. On the left, that leaves me with a negative 11y, and then is greater than 55. So that was step one. Actually, for this one, step one and step two combined. Next, I need to multiply or divide by the number with the letter, the number in front of the variable, what we call our coefficient. Since it is negative 11 times y, I am going to divide by negative 11. And I want to focus in on what I just said. I said we are dividing by a negative 11. Since I am dividing by a negative, that means my inequality symbol, the greater than, now becomes a less than. And then I need to simplify 55 divided by negative 11, which gives me negative 5. Now let's go ahead and write that answer in the other two representations. First, we have our set builder notation. I use my squiggle bracket to say that my answer is any y as long as y is less than negative 5. And then I can make my number line. Let's start with my negative 5 in the middle, then negative 4, negative 3 to the right. On the left, I need to go as far as negative 7, then I have negative 6. This is for y is less than negative 5. Since we don't have the or equal to option, I'm going to put an open circle because negative 5 is not actually part of my answer. It's just a boundary to start from. And in order to get all the numbers less than always means to go to the left, because on a number line, as we move to the left, our numbers get smaller. So this right here is a full example. This is pulling from our knowledge of solving two-step equations, and we are just adding to it the things we must remember about inequalities. Let's go ahead and look at a few more examples. All right, next two examples. Let's start on the left. I have 43 is greater than or equal to negative 4y plus 11. Like before, I need to start by adding or subtracting the piece that does not have a variable attached to it. Well, that's this plus 11. I need to subtract 11 on each side so that I now have 32 is greater than or equal to negative 4y. To finish solving, I must multiply or divide. In this case, since it's negative 4 times y, I should start by dividing by negative 4. Now that's something really important. I just said we're dividing by a negative 4. That means my inequality symbol must flip to the opposite, and I can go ahead and reduce. 32 divided by negative 4 is negative 8, and that negative 8 must be less than or equal to y. Before I can say I'm done, I do need to flip this around so that y is on the left. What I've talked to my students about is we went ahead and we flipped the symbol. Now I need to go back and flip the entire thing. When I flip the entire thing, the y is now on the left. I need to take the symbol. Notice how the symbol is opening up towards the y and saying that negative 8 is less than. That means y is greater than or equal to negative 8. The whole thing is flipped around. I can then write it in set builder notation, say that my answer is any number y as long as y is greater than or equal to negative 8, and I can make my number line. Put negative 8 here, and this time I think I'm going to count by 2's. So negative 6 and negative 4 to the right. On the left, I have negative 10 and negative 12. My symbol says greater than or equal to. That means when I put my circle on negative 8, I need to go ahead and fill it in because negative 8 is one of my possible answers. It's part of my answer. And then I go to shading. For all numbers greater than or equal to negative 8, I go to the right. Another example, only 3 more to go. Looking at this example, I see x divided by 2 minus 3 is less than or equal to negative 2. And again, I need to start by adding or subtracting any piece that does not have a variable over to the other side. And my eye should go right to that 3. Since it says minus 3, I should add 3 on both sides. And I get x over 2 is less than or equal to 1. And now I can go back and deal with that x divided by 2. Instead of having x divided by 2, we've talked about how you can multiply by 2 or even say 2 over 1 on each side to get x is less than or equal to 2. Notice, I multiplied by a positive 2, so my symbol does not change, leaving me with this final answer. We'll go ahead and write it in set builder notation. My answer is any number x as long as x is less than or equal to 2. When I go ahead and make my number line, I know that 2 is part of my answer because it says I can have it equal to 2. And then for all numbers less than, I shade to the left. Only 2 more to go. And if you need to, pause and go back and re-listen to these examples so that you are ready to go. Here are our last 2 examples. Let's start on the left. I again need to start by adding or subtracting anything away that does not have a variable. I see that that plus 1 has no variable attached, so I'm going to start by subtracting 1 on each side. To get 0 is greater than or equal to negative x over 3. Now this next step is something that has been different in each of my classes, so let's pay attention and be careful. There's a couple ways you guys can approach this. The quickest way would be, since I see a negative 1 over 3, I could multiply by negative 3 over 1. That is one possible way. Or we could do it in 2 steps. I'm going to go ahead and do it this way just for simplicity. Now, on the left, I need to simplify negative 3 times 0. That reduces to 0. And I need to remember what I just said. I am multiplying by a negative 3. So I need to flip my symbol. And on the right, I am left with x. We know the variable needs to be on the left. So in this time, I need to flip the entire thing. And since 0 is less than x, that means my x is greater than or equal to 0, giving me the set builder notation of my answer is any number x as long as x is greater than or equal to 0. And then I can go back and make my number line. 1, 2, 3, 4, 5. Do 0, 1, negative 1, 2, negative 2. Since my answer is greater than or equal to 0, 0 is one of my numbers. And for greater than, I shade to the right. Our last example. 7 is greater than x minus 2. So I have a minus 2 that has no variable. I should go ahead and add or subtract it away. So I'm going to add 2 to get 9 is greater than x. What's awesome about this is actually a one-step inequality disguised in our set of multi-step inequalities. Since it's only a 1 in front of that x, I don't need to multiply or divide, but I do need to swap my x over to the left so that x is less than 9. And now I'll write it in set builder notation. My answer is any number x as long as x is less than 9. And now I go and I make a number line. 1, 2, 3, 4, 5. See, 9. Maybe I'll count by threes. 12, 15, 6, and 3. Since x is less than 9, 9 is not one of my answers, but I'll still put an open circle there. And less than means I shade to the left. You need to pause the video and go back and rewatch any of the examples you feel you need to see again. When you feel you're ready, you're going to continue the video, and we're going to have 3 examples for you to try on your own. Here are your 3 examples. Go ahead, solve these three in your notebook using your notes as a guide. And then if you have any questions, please bring those questions with you to class.